Welcome to Conservation of Momentum, the third experiment in the At Home with Physics series. I want to introduce you to the game of poo curling, an indoor sport soon to reach Olympic proportions. Here on this carefully constructed plastic track, we are going to roll these poos. Notice the poos come in two colours depending on the previous night's meal. The poos roll down and are meant to land somewhere near this target. The plane is of course inclined. This is to offset the effect of friction with the effect of gravity. So by balancing friction with gravity, we achieve a constant velocity down the slope. Here is the game in action, and you'll notice that it's not the easiest game in the world. As you might know, achieving a target with a poo can be difficult. Oh, bang on, plop. Now, I've removed the board and drawn in three lines in fact, 30 centimetres apart to give me distance. And now I have to make the poos sticky. You'd think that a game such as this would come with sticky poos, but unfortunately the poos are not sticky at all, and I had to add some sellotape to make them sticky. So now, the experiment. Centrally placed, the poo which is going to be collected. On the left, I'm going to roll a poo down. The timer is constantly running. There they are, rolling off together. Now, very difficult to do at that speed. So I've slowed it down. There we go in slow-mo. There's the poos being collected and rolling off over the final line. Now, for the time, all I have to do is freeze the frame at the point I release the poo over the first line and take the time. And then I note the time on the left, a half second or so later when the two poos collide. And finally, I take the time when the two poos, still adhered together by the sellotape, roll over the final line. I do need to mass the poos. This is the slightly more carrier poo, and this is the lighter poo which is collected, perhaps some meat extract. The momentum before the collision is just the momentum of the dark brown poo. That would be momentum before, which of course is equal to the mass times the original velocity. The original velocity u is the length it went, 0.3 of a metre, over the time, which from the video we were able to spot was 0.52. That was the time it took to travel the first 30 centimetres. That calculates to be 0.58 metres per second. So we have the mass 0.019, 19 grams of the poo, times its velocity 0.58, and that becomes 0.01102. And the units for this figure are, the units for the answer, momentum before, are kilograms meters per second. So the total answer, 0.01102 kilogram meters per second. For momentum afterwards, we need to add the masses of the two poos together. So, still we have mass, but we have the two masses now, times the velocity afterwards v, which again we can calculate in the same way. 0.3 is the distance it travelled. The time it took was 1.12 seconds, giving us a velocity of 0.27 meters per second. So, if I just write it down like that, the total mass 0.039, 19 plus 20 grams. Velocity 0.27. That becomes 0.01053 kilogram meters per second, which, compare it to the one for before, 0.01102, is pretty close. And within experimental error, we have proved the conservation of momentum. I love it when a bit of poo comes together.